We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing that Chandra does is take these superb, sharp images.
Nothing as beautiful as Chandra sailing off on its way to work.
Did you know that galaxies don't like to be alone? It's not that galaxies feel a social need to congregate with others. Rather, it's their gravitational pull, even across the vast distances of space, that can cause galaxies to form clusters that can contain hundreds or even thousands of individual galaxies. Clusters of galaxies are, in fact, the largest structures in the universe that are held together by gravity. Because of their immense size and mass, galaxy clusters are extremely useful as tools to probe a variety of questions about the universe as a whole, as well as properties of the clusters themselves. Dr. Christine Jones of the Chandra X-ray Center discusses the importance of galaxy clusters and the wide range of astrophysical topics they can address.
Since clusters are so large and so massive, they're a great place to take an inventory of the mass in the universe. In particular, how much is luminous matter and how much is dark matter. We also can study the individual galaxies and clusters and learn what kind of galaxies live in different environments, and how the galaxies, which are often moving in the cluster at speeds of 1,000 kilometers a second, interact both with each other and with the cluster gas. In addition to being massive, clusters are so luminous that they can be observed back to when the universe was only half its present age. Comparing the properties of distant clusters with nearby ones allows us to see both how clusters grow over time as smaller clusters fall into them, and also lets us constrain important cosmological parameters.
While galaxy clusters are indeed comprised of individual galaxies, that is not their entire story. That's because these clusters are filled with colossal clouds of hot gas. These clouds have temperatures as high as 100 million degrees and much more mass than all of the stars in the galaxies in the cluster. Because this gas is so hot, the only way to observe it is through X-ray telescopes like the Chandra X-ray Observatory.
One of the incredible insights we've seen with Chandra is the impact that outbursts from a supermassive black hole at the center of the central galaxy in some clusters has had on the gas in the cluster. In several dozen clusters, we've now seen X-ray cavities, some with sizes larger than the entire Milky Way, where expanding radio lobes from the black hole have pushed the hot gas out of these regions. The energy in these outbursts is enormous, more than billions of supernovae. In a few clusters, we've also seen shocks in the gas that are produced by these outbursts. With these Chandra observations, we can measure how much energy has come out since the outburst began, how long the outburst lasted, and how often these outbursts occur.
One of the most important questions galaxy clusters can help astronomers address is concerning dark matter. Dark matter is an unknown substance that comprises 90% of all the matter in the universe. Using Chandra and optical telescopes, scientists have been able to find direct proof of the existence of dark matter for the first time.
In clusters, as in the universe, most of the mass appears to be in the form of dark matter. But while we can't directly see where the dark matter is, we can determine how much there is and where it is. One of the best examples of a merging cluster is one we call the bullet cluster. Most of the gas in this subcluster has been stripped off and pushed back from the subcluster galaxies. So the question is, where's the dark matter? Some alternative theories of gravity have suggested that gravity behaves differently on large scales, and that in clusters, the hot gas alone might be enough to provide the gravity. What we found for the bullet cluster was that observations of distant galaxies behind the cluster showed that their light was distorted into arcs by the dark matter in the cluster. These observations showed that the dark matter was concentrated into two regions, one on the large primary cluster and a second at the front of the bullet. Since the X-ray gas is no longer at the front of the bullet where the dark matter is, the gas can't be making up the dark matter. So while we still don't know what does make up the dark matter, we know it's not the gas and must be something different that interacts much less than the gas does.
Galaxy clusters are proving to be some of the most fascinating structures in the universe. Their mind-boggling size makes them incredibly important objects to understand. Scientists have made important progress in learning about galaxy clusters, but many more questions and mysteries have emerged. This will keep these objects at the forefront of astrophysical research for years to come. For more information about the Chandra X-ray Observatory, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.